All right, quantum numbers. So there are 4 quantum numbers. Okay. So the atom, we got our protons and neutrons in the nucleus, and then we have our layers. And each layer is a level of n. Okay, so n is your electron shell that you're on. Okay. So let's say n equals 2. All right. Your L, all right, goes from, your possible L's, go from 0 to n minus 1. All right. Your L level is your subshell. Essentially your room on the level. Okay. So if n equals 2, L's value goes from 0 all the way up to all the positive integers to n minus 1. So n minus 1 is 1. So for our example here, L is 0 and 1. Now, these numbers have letters that show what they are. For my L's, a 0 means S, a 1 means P, a 2 means D, and for our intents and purposes, we're going to stop at F, which is a 3. Okay, so N tells you what level you're on, L tells you what subshell or room you're in, and then there's M sub L for each L. So there'll be one, so this would be S, and this would be P. So in our case, there'd be one for S, and there'd be one for P. Okay. MLS, MLP. And we come over here, and how do we find M sub L? How we find M sub L is it goes from negative L to positive L in every integer in between. Okay, whole number in between. So for 0, there's only 1. Okay, and for P, it would be negative L, which is negative 1, up to positive 1, and everything in between, whole numbers, so 0. So we'd have 3. These are known as my orbitals. Okay. And then last but not least is our spin, because no 2 electrons could have the same 4, so that's always plus or minus a half. Okay. So they all build on one another. They all build on one another, knowing what level I'm on. So let's do another one here. Okay. And if we say n equals n equals 4. Okay. All right, what are my L possibilities? So L, again, goes from 0 to n minus 1. So 0 is one of them. N minus 1 is 3 is one of them. And then everything in between. So 0, 1, 2, and 3. Now, this would be an S. This would be P. This would be D. This would be F. Now, if they want us to list every single M sub L, I need an M sub L for the S. Okay? That's 0. Negative L. So remember, this is negative L to positive L. M sub L of P. Negative 1, 0, positive 1. M sub L of D. Negative 2, negative 1, 0, 1, and 2. M sub L of F. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, and then the ms of each one of those plus a half or minus a half, like so. Now the question is, are you being general? So we're looking for an electron and it's on the 4th floor. Where are its possible locations? It could be in an S, it could be in a P, it could be in a D, it could be in an F. Well, if it's in the S, it could be in the S orbital. If it's in the P, it could be in one of the 3 orbitals of P. If it's in D, it could be one of the 5 orbitals of D, or F. So we're basically saying it's in, that area. It'd be like saying if we were on campus, the person we're looking for is in building 4. Okay, well, if the person's in building 4, what are the possible rooms? Every room in that building is possible, so we have to list all that. But let's say we got more specific. Let's say we said that the electron we're looking for is in the 4p, and we want to list the quantum numbers. All right, now we're getting a little bit more specific. Okay, so my L value is going to be, all right, for this, since I'm in the P, and I know I'm in the P, it's going to be 1. So we narrowed it down. Now we're saying the person's in 418. Okay? We're being more specific. I don't have to list everything that's in n equals 4. Then the m sub L would be -1, 0, and +1. And my ms would be the plus or minus a half. So we'll say plus a half here. Now we can get even more specific. What if it was drawn out and it said, I want to know this electron right there, and I want to know its quantum numbers. So now we're saying it's in that room and it's in this specific seat. Okay, so we went from general, n equals 4, to a little bit more specific what subshell it's in. Now we're saying what specific orbital. And the orbitals are usually numbered by their m sub L, left to right. So this would be even more exact. N equals 4, because here's my n value. Here's my L value. L is 1 because it's P. My m sub L, now we're talking about a specific electron, is 0. And the ms, whatever you want, plus or minus a half. So the question is, are you being asked a general location, a more specific location, or the most specific location for the electron? Does that clear it up? It's on you, Vaughn. It's on you to say whether it's plus a half or minus a half. So let's say, for instance, okay, if there's only one electron, you call it. But let's say there was 2 electrons. Let's say there was the black electron and the blue electron, and I want to know the numbers for the blue electron. Okay, I want to know the quantum numbers. Well, it's still on the 4th level. It's still in the P. It's still in the m sub L of 0. It's still sitting in that orbital. The thing is, no two electrons could have the same 4 quantum numbers. So therefore, if I call the black one plus 1/2, I have to call the blue one minus 1/2. So that the plus and minus only really comes up if you're writing about 2 electrons in the same orbital. Cool beans, cool beans. Roughly the same as last time, Tori. I mean, I could look right now. I made these up over the weekend. Let me see here. Assignments. $15 total questions. $15 total questions. I mean, I would know how to do this. You know, I would know how to do electron configuration. I would know how to use the Rydberg equation. So, I mean, important equations that we would need is C equals lambda nu. Energy equals Planck's constant times nu. Energy equals the negative Rydberg value 1 over n final squared minus n initial. Like that. De Broglie-Hayes equation. Wavelength equals Planck's constant mass times velocity. So I would know how to do one of these. That's in the homework. I would know how to do one of these. These are all in the homework. If I were looking at the math problems wise, I'd know how to do electron configuration. And see, the thing is, this is really one chapter. I know it says 2 chapters, but the old edition of this book, that if you look at chapter 8's like that big. Because they just ended, chapter 7 would end with electron configuration. And for whatever reason, they did, they separated that electron configuration and made it its own chapter now. Again, in my opinion, it was so that they could say, hey, there's a new edition of the book. So those are the equations. I mean, I'm looking right at the exam right now. So if I'm telling you these are the, if I'm telling you these are the equations. Plus, guys, exam 3 had a 10-point curve because there was a problem that was had the wrong answer marked 10 points. So I added the 10 points back to everybody. But there were 90s and 100s, so there's nothing I could really do to add more points to it. I'm looking at it right now. Quantum numbers, the math problems, electron configuration. Yeah. There's 15 questions on it. So if I'm narrowing this down to those types of problems, the homework that I assigned, like 7.7, 7.8, where you're finding wavelength and frequency. Rydberg equation problem is, where is it now? It's on this page, right? Yep. 7.24, 7.23, the de Broglie equation, you're looking at 17.39a, 7.40a, 7.41, 42. Your quantum number stuff, 7.49 and on. And then chapter 8 deals with your electron configuration, orbital diagrams and things like that. And then we'll talk about, the periodic table and stuff in Chem 2 when we start that off. Yeah, the exam's going to be available all day. I have it set up for 8 a.m. to 11:59 p.m., Ellen. One and done. All right, what else, guys? while you have me. For those of you in Chem 2, you'll be getting an email as long as you get through Chem 1 about Blackboard being set up and all that fun stuff again. I'll be working on that over the weekend. All right, anything else I could do for you or go over?